A large percentage of lightning comes from cumulonimbus clouds. When what you have is you have these excess electrons that have a negative charge, and they typically form in the bottom of the cloud. And then you have the ground that has a positive charge, and that charge is caused by the negative charge above. And when the difference between the Earth, or whatever is holding the positive charge, becomes great enough, the spark jumps across the space, and you have lightning. To start off, we have this channel of ionized air, and that's referred to as a stepped leader. And it contains plasma, and it shoots to the ground, and the process happens very, very quickly. Now, we may start out with one stepped leader, but that can quickly change. It's similar to, think of a river flowing and splitting up into channels, or a bunch of channels flowing into a river, the inverse of that. Or think of it as the branches of a tree, how the stepped leaders split up. Now, when lightning hits the ground or its target, typically you'll have around 30,000 amps of current, and they will shoot back up to offset the negative and the positive charge imbalance of electrons. And that can actually get pretty hot inside. The temperature can get over 50,000 degrees Fahrenheit, which is significantly hotter than the sun. Now, since lightning travels much faster than sound does, you'll typically see lightning, and then you'll hear it first, and then you'll hear the thunder later, maybe a few seconds later, depending on how far away it is from you. Now, there's typically three types of lightning, or three main types of lightning. Now, the first is cloud to ground, which is most of the stuff that we observe, and we were showing pictures of earlier. There's also intracloud, which occurs just inside of a cloud, and then there's cloud. Now, all of these have obviously the negative charged electrons and beating the positive charged electrons, where they offset. Now, these can be particularly dangerous for humans or animals. It can cause internal organ damage, fry them, nervous system damage, and it may result in death. Now, when it hits a tree, it's not quite as bad, but it can vaporize the sap, cause a steam explosion, destroy the trunk. When it hits sand, it's less bad. They have these things in the sand that sometimes may melt or may harden, and they're called fulgurites. Now, that's caused when the plasma channel melts. Now, lots of houses and buildings have lightning rods on them, and what that does is that directs it to the ground to avoid potential damage. Lightning isn't just restricted to normal clouds and stuff like that. You can have volcanic ash, and that can cause it too. Again, we're looking for the negative charge and the positive charge being different. Now, there's some parts of lightning that are not specifically or not completely understood, such as what specifically triggers it to hit one thing over another, or causes it to go in one direction or over another. It is also very unpredictable. It's very difficult to predict when and where it's going to strike, and how often, and so forth like that. And that essentially wraps up our overview of lightning. Thank you for watching.